Okay, so this first one here says, write the formula equations for the reactions between each of the three oxides and water that result in the production of acids responsible for acid precipitation. So these ones you're just literally went into the reading to get. So one of the non-metallic oxides is sulfur dioxide, right? Sulfur dioxide gas plus oxygen makes sulfur trioxide. Right, and then we've got to balance this out. So we need a 2 and a 2, right? So then what ends up happening is that SO3 reacts with water to form sulfuric acid, which is actually one of the reactions we'd already written out. And then another reaction that happens is when NO2 reacts with water, we end up getting nitric acid. Okay, so actually when NO2 reacts with water, it's able to produce two different types of products. So it can make nitric acid, but it can also make nitrous acid. So obviously these two are strong acids, which are more devastating to changing the pH when it comes down. But HNO2 is weak. Obviously still not good to have acid or acidic components going into the water systems, but or soil and all that, but obviously not as devastating, right? And then this to be properly balanced here, we'll have a 2 and a 2. Okay, so let's look at number 2. So number 2 says, explain why the release of aluminum ions into aquatic ecosystem poses a serious threat. So this goes back to what we learned from even the beginning part of this chapter. So when aluminum is in water, really it forms that, oh my goodness, I was writing H3O here. It forms that water complex, right, with the aqua hexoaqua ion. When that reacts with water, it then will produce hydronium, right? And the aluminum will have 5 waters and then a hydroxide, and this will be positive 2, right? So this is creating an acidic situation, right? So it behaves like a weak acid. All right. So number 3, how does the process of scrubbing remove sulfur dioxide from exhaust streams at coal-fired power plants and smelters? Include the relevant chemical equations in your answer. So really, you're just looking at going through the reading of the theory behind all this. But essentially, what we're doing here is you would write out the reactions. So you would have calcium carbonate, which is the main component in the limestone, which will then create calcium oxide and carbon dioxide gas. And of course, then the calcium oxide will combine with the sulfur dioxide, right? So calcium oxide will then react with the sulfur dioxide gas. And this creates almost like a sludge. Okay, well, it creates a solid. It kind of binds it. So what ends up happening is the calcium, the limestone component in the scrubber system, when it's involved in the combustion chamber, basically will create these products. Then what ends up happening is when that calcium oxide combines with SO2, it almost acts like a filter, kind of captures that sulfur dioxide before going out into the atmosphere, right? And we know that this compound will create sulfuric acid if released into the water system, right? So essentially what's happening here is the suspension of the calcium oxide is sprayed into the exhaust before it reaches the smokestack. So that way that this sludge of calcium sulfite can actually be removed instead of having the gas escape into the air. And that's essentially it for this section. We're officially done chapter 6.